So let's continue with our playlist, but before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So I'll be solving the problem, reverse a given linked list. So you'll be given a linked list and your task is to reverse that particular linked list. So imagine you are given this particular linked list. If I try to reverse it, the reversed linked list will look something like this, right? So your task is to return me the new head of the reversed linked list. Now, if this problem comes up in an interview, what is the extreme naive solution that you can think of? Like, I can think of, what if I take all of these elements out, right? That's the first thing. Let's take all of these elements out. We need a data structure to store it. So maybe I'll take a data structure stack. Why stack? You'll understand why after I take it out. So first, let's stand at the head of the linked list. So I'll take a temporary variable because we do not want to alter the head. It might be used afterwards. So what is the first data? 1. Let's take it and put it into the stack. Right after that, let's move temporary to the next. What is the data? 3. Let's take it, put it into the stack. After that, let's move it into the next. Take the data, put it into the stack. After that, let's take the next data, which is 5, and put it into the stack. After that, move the temporary, and eventually you will reach null, which means you have traversed the entire linked list, right? Once you have done this, let's do our next step. So the next step is, again I'll take temporary and this time I'll place it on the head again. This is the reason I did not alter the head. So this time when I'm standing at the head, what is the data? The data is 1, but if you're reversing, the 5 should be here, isn't it? How do you get this 5? You look at the stack, and stack is something as last in, first out. So what is the last entered element? 5. So if you do stack.top, you'll get this 5. You'll get this 5. This is why I took something as stack. So you'll take this 5 and what you'll do is you'll replace this. Done. After this, you'll move the temporary to the next one. Again take the next one, which is 2. Replace the data. After that, again move to the next. Again take the top at the stack, which is 3, and replace this. After that, again move to the next. This is 5, take 1 and replace it. After that, you will reach null. The moment you reach null, you will observe a couple of things. Your stack, the stack you took is empty, and at the same time, your linked list is reversed in terms of data. Now this is very important. You have reversed the linked list, but just in terms of data. So can I write the code for this one? Probably yes. So this algorithm will be in 2 steps. One is traversal, putting everything into the stack. The second is taking out of the stack and putting back to the linked list. So let's do the step 1. Can I say the step 1 will be, I'll take a temporary and put it at the head. I'll also take a stack. So assume your stack is named as ST. Again, depending on your language you're using, you can code it across. Let's do the traversal. So the traversal will go on till I don't reach null, right? What's the first step? Put it into the stack. So stack.push or stack.add, depending on your language. Take the data and put it into the stack. Once you have done it, ask temp to move to the next. So temp will move to the next, which is basically temp of next. So this is the step 1 of the algorithm where we are taking all the data and putting it into the stack. What is the step 2? Taking back from the stack and putting it into the linked list. So let's do it. So I'll again reassign temporary to the head. And this time what I'll do is, I will again keep it moving till it reaches the last, which is null. Okay, let's do it. So what we say is, temporary, your data should be replaced by whatever is on the top of the stack. Once you have taken the top, depending on your language, if your language needs stack to pop it out, so basically you delete the top element. It's required in some languages, it's not required in some languages, depending on the language that you're using. And after that, move the temporary to temporary next. So this will be the brute force, and can I say this will be the step 2. So 2-step algorithm, rather a 2-pass algorithm. What will be the time complexity of this algorithm? Can I say this is bgo of 1 and this is another bgo of 1. So in overall, the complexity will be bgo of 2n. What will be the space complexity? It will be bgo of n because you're storing all the elements into the stack. So this will be the time complexity, and the space complexity. This is where the interviewer will not be happy with this one. That is basically the space complexity, and he'll ask you to optimize it. This is when we move on to the optimal algorithm. So the previous algorithm was using an external space. What we need to do is we need to optimize that external space. What that means is you cannot use any external data structure, which means we have to play around with the links. That's the only way. So if I'm reversing the linked list, it technically means this one will be the new head of the linked list, right? So can I say if I'm reversing it, then if 1 stays here, 3 stays at the same place, 2 stays at the same place, 5 stays at the same place, at the same memory, data is same, and this becomes my new head of the linked list. I've reversed it. So this will be my new head. So this new head of next will be pointing to 2, 2's next will be pointing to 3, 3's next will be pointing to 1, and 1's next will be pointing to null. Correct? Am I right or not? I am right. We need to somehow find out a logic such that these links are reversed. Let's observe. If I take this particular node, which is the node having the data 2, the 2 is basically this node has the data 2 and the next is pointing to 5. What we need to do is the data stays intact. We need to make sure this next points to the previous one. So I'm basically changing one link. If you look at every node, let's look at every node. The node with 1, I'm changing this node. The node with 3, I'm changing this node. The node with 2, I'm changing this node. The node with 5, I'm changing this node. Somehow, I'll have to play around with the next and make it point backwards. This is what I have to do. Can I do this? Let's try thinking. So what I'll do is, I'll just take one node, just to understand. So this one node has a data. Let's call it some data. It's pointing to the front and it definitely has a previous element. All of us know it. What is the task that we need to do with one node? That's basically taking this and pointing it to the back. Imagine you have the previous node. Just imagine you have the previous node. How can we do it? So there's the node which it is pointing to, right? And we can call it as the maybe something as front node. Yeah. So just assume you are standing at this particular node and this node is called as temporary. What we technically need to do is temporary next should be pointing to previous. This is something we have to do, which will mean this node will be pointing to back, right? Next job that I have to think is, hey, wait, if you point this, how can you go to the next node? Because we have to somehow do the same thing for the next node as well. How can I go to the next node? So what you will do is, before replacing this, just make sure you store the front node. So you say temporary dot next. So what I've done is I've stored it. After that I do the step. So this step is performed after storing. So what happens is, now this is done. What is the next job? The next job is technically moving the temp to this. Just think out loud. It is. So can I say temporary can go to front? And if I just look at the larger picture, this will again be pointing to someone. I'll again have to do the same job of rotating it back. I'll again have to do the same job. So thereby I need this previous. So I need to make sure I am preserving this previous. So what will happen is I'll say preserve or rather previous. I'll have to preserve it. So before moving, make sure previous is temporary. So what I did was, let's recall what I did. So basically previous was here, temporary was here. So what I did was I said previous, since it is done, the rotation of the pointers is done. Previous, you can go ahead. So this line will do it, right? After that, I'll say the next line. So the next line will take it forward. And then again, you're on the same cycle when you can do the same job, right? You can again make sure the same cycle is repeated. So what I'll do is, I'll try to do this algorithm. rather I'll try to do a dry run. Let's do it. So what I'll do is I'll write while temporary, let's do it till it reaches null. Very simple. What are the steps? What I can do is I can straight away copy this steps. Let's say copy, and after that let's over here paste. So I'll just paste the same code over here. Done. Let's try to do it now. So I have to perform this algorithm for all the nodes, right? So what I'll do is I'll start off with this particular head. So can I say temporary will be head? I can. Afterwards, what can I say? I know one thing. After the reversal, this one will be pointing to null. This one will be pointing here. This one will be pointing here. And this one will be pointing here. I know this. So I need to make sure this first node is pointing to null. So maybe I can take a null and I can call it as previous. So I'll take a previous and I'll call it as null, right? Let's do the step. What's the first step? Front. So let's assign front here. So this step is done. What is the next? Temporary dot next equal to previous. So what happens is this temporary dot next is pointing to previous. Nice. What is the next? Previous equal to temporary. So previous goes to temporary. Perfect. What is the next? Temp equal to front. Temp goes to front. Perfect. So this is one step. This is one step. So we are done with one step. What is the next step? Let's again do the same thing. Front equal to temporary. So front goes to temporary dot next. Right? What is the next? Temporary next previous. So basically what happens? Temporary is next, which is this I'm erasing, goes to the previous. Perfect. What is the next? Previous equal to temporary. Goes here. Perfect. What is the next? Temporary equal to front. Goes to next. Perfect. So I'll just erase this and erase this as well. Done. Let's do the next step. Front equal to temporary next. So front goes over here. Perfect. Temporary next equal to previous. So erase temporary is next equal to previous. Done. Next. Previous equal to temporary. Take it. What is the next? Temporary equal to front. So the temporary goes here. So this is also done. Let's erase this. Perfect. What is the next? Front equal to next. So front goes here. So I can just take the front and go it here. Next, temporary next. Temporary next. So basically this erases itself. Temporary next points to previous. Done. What's the next job? Previous equal to temporary. Take the previous to temporary. What is the next? Temporary equal to front. Let's take temporary equal to front. Done. Stop. Then and there. And if you carefully see, temporary would have reached null, right? So this while loop will end. This while loop will end. What is the new head of your linked list? Previous. So you can go ahead and return previous because that is your new head. Done and dusted, isn't it? So let's quickly get back into the code editor, and as you can see, I've written the exact same code. I'll hit the submit button and it will be working fine. Again, the same code can be submitted in Java as well. I'll go to Java and over here I'll paste the same code. It's the exact same thing. What you just need to do is need to change this pointers and then this one to dot, and this goes in lower caps. Perfect, and should be good. Let's quickly, okay, this one will also be lower caps. Let's try to run this off and see if it is running fine. Should be. It does. Let's quickly submit it. So it will be running fine. So it is running absolutely fine. Now coming back to the code editor, if I ask you, what is the time complexity? Can I say the time complexity is big O of n because I'm doing it in one pass? And if I ask you the space complexity, can I say it's a big O of 1? Because what we are doing is changing the links. We're not doing anything. We're just changing the links. So before I start off with the recursive solution, please make sure that you would have seen my basic modules of recursion. In case you haven't seen it, I'll be leaving the link in the description. Go back and watch it, understand what recursion is, and then you can understand this particular problem. Why is recursion used, or how do we use recursion? Generally, we are given a problem statement. which is a large problem statement. Like in this case, reverse an entire linked list. You cannot solve it in one step. So what recursion does is, it breaks it into a smaller problem. And then again it breaks it into a smaller problem. Then again it breaks it into a smaller problem. It stops the moment it can solve a smaller problem. And then it tries to give it back saying, hey, I solved the smaller problem. Then this one says, hey, I can use that and solve myself. Again returns and says, I can use this and solve myself. He returns and this can say, I can now solve it myself. And eventually you solve the bigger problem. You break it down to small, and eventually extract and solve it. This is how technically or generally recursion works. How will we make it work for reversing a linked list? What are we given? We are given the head of the linked list. So basically I can consider this as the bigger problem. So what we will try to do is, okay, we have a bigger problem with 4 nodes or n nodes. So we'll try to solve it for 3 nodes. Then we will say we'll try to solve it for 2 nodes. Then we'll say we'll try to solve it for 1 node. So basically the problem is with 4 nodes. I'll try to solve it for 3. I'll try to solve it for 2. I'll try to solve it for 1 node. So basically if I'm able to solve it for 1 node, I can solve it for 2. I can solve it for 3. I can solve it for 4. How? Let's understand. Let's try to solve the smallest problem, which has 1 node. I'll just write this 1 node. So imagine you have 1 node. How can I solve this? Do you even need to solve it? If the linked list has 1 node, you don't need to reverse it. This is going to be my reversed linked list. You just return it. You just return it. So maybe this can be my base case, because base case is the smallest problem that you try to solve. So this will be my base case, the smallest problem. Perfect. So maybe I can try to write the base case. Let's try to write the base case. So reverse, imagine head is given to you. And you know, this is the bigger linked list. But you know, the smallest version is if either you're given an empty linked list, which means it's a null, if it's an empty linked list, or it's a 1 element linked list, which means the next is pointing to null. In both the cases, you stop then and there. You stop then and there, and you return the head, and you return the head. Quite simple. Stop whenever it has 1 node. Okay, we're done with 1 node. What is the next smallest problem? With 2 nodes. Maybe let's try to solve it. So I have 2 nodes, right? So maybe I'll write it somewhere here. I have 2. 2 is pointing to 5 and 5 is pointing to null. I need to reverse it. After reversal, can I say 2 will be pointing to null, 5 will be pointing to 2, and this will be my new head. Can I say this will be my new head? How can I solve this? You know one thing, this has 2 nodes. So if you call the recursion for 1 node, it will return you this node itself. It will just return you this, because whenever you try to solve the problem for this, you get the same back. How can I solve this? Let's try to understand. Can I say this as of now is my head of the linked list? This as of now is the head of the linked list. Okay. What is the next node? I'll be like this one. Front node is 5. What do I need to do? I basically need to make sure the front is pointing to head and the head is pointing to null. And this is my new node. This is my new head of the linked list. Because after reversal, 5 will be pointing to 2, 2 will be pointing to null, and this is my new head that I will return as an answer. I'll return as an answer. How can I do this? Very simple. You say front, your next will be head. You'll be like, why not? Erase this, point it, done. Next, head, your next will be null. Perfect. Erase this, point. So basically I have everything ready. Can I say this front will be my new? Yes. So I'll basically return this front, which will be my new node, which will be my new head. Remember this. 5 is your new head now. 5 is your new head. I have solved the problem for 2 nodes. So I solved the problem for 2 nodes. It's time to solve it for 3 nodes. Let's try to do it. For 3 nodes, I have it's starting with 3, going to 2, and going to 5, and the 5 goes to null. So it's a problem where the head is at 3 and I have 3 nodes. I need to solve it. So what I will do is, I'll call the sub problem, or rather I'll call the sub problem, and I'll ask the sub problem, can you solve it for 2, 5, x? So basically a linked list with 2 nodes. What will the sub problem return? The sub problem will solve itself and it will return a new head where the head is basically starting from 5 pointing to 2. So this is the new head which it will return, and the 2 is pointing to null. So this is what it returns if you call the sub problem for 2. So basically the pointer should have changed because these are in memory nodes. After you call the sub problem and it has returned, you'll have something like 2, the same thing, but this time you'll have 5, and the 2 will be pointing to null. Remember this, the 2 will be pointing to null. That's very, very important. The 2 will be pointing to null. So you'll call the sub problem and the sub problem will solve itself and you will get the new head here. How can you solve now? You already have this, and you just need to make sure this is pointing here and this is pointing. So what you'll do is, you'll again do the same thing. You'll take a front and you'll again perform the same step, which is front's next equal to head, because this is your head. Head's next is null. So basically what happens when you say front's next, so front's next goes and points to this. When you say head's next, so head's next goes and points to null. What will you return? Very, very important. What will you return? This is the new head, so you'll return new head. You'll return new head stating, if I've been given this problem, the new head will be this. So I've also solved a problem for 3 size linked list. Done. Wow, easy. Let's try to do it for 4 size linked list, and I think we will be done. So I have 1 pointing to 3, pointing to 2, pointing to 5. So what will happen is, this 4 size linked list will call the reverse function and it will pass this much. It will say, this is my new head, please give it reversed. This is my new head, please give it reversed. And he will do it. So basically you pass it. What happens is 3, 2, 5. 5 points to 2, 2 points to 3, 3 points to null. And this will be my new head. This is what will be returned. So after you've called the sub problem, it will give you the new head, which is 5. So eventually I can say these links will go off. After you call the sub problem, what will happen is, you will have new links. This one pointing to this one pointing to this, and this one pointing to null. Remember this. This is what you'll get. The new head. How to do the next step? Quite simple, the same thing. This is my head. So we'll do the same thing. We'll say, hey, front, you're next. Should be pointing to head. Hey, head, you're next. Should be pointing to null. Done. Once you're done, you've returned the new head. So I've solved a problem for 4 nodes. So I can do it for 5, I can do it for 6, I can do it for 7, I can do it for n as well. Because we have done it. Yes, we have done it. So what we technically did was, we started off with a problem, or rather reverse, if I have to write it, reverse of 4. We called for reverse of 3. We called for reverse of 2. We called for reverse of 1. So this 1 was easily solved, which again helped us to solve 2, and then 3, and 3 helped us to solve 4, and we return the new head eventually. Got it? So if I have to write the code, it's very simple. Let's go back here. So this is for a node with 1. So I can write, this is for one node or 0 nodes. So I can solve it for 1 node or 0 nodes. After this, what we do? Imagine it's a big linked list. You don't solve it straight away. What you say is you break it into sub-problems. So you say, hey, node star new head. Maybe I'll call the reverse again. And I'll ask it, hey, can you solve it for the next? So basically what I've done is, if initially you got a 4 length, I call it to solve it for 3 length. I call it to solve it for 3 length. Then the 3 calls to solve it for 2. Then the 2 calls to solve it for 1. That's how it works. So basically it will go in depth. And once you have the new head coming back, what did we do? We did not do anything. We said node star front equal to, we need the next. This new head is not the next. Remember this? This new head is not the next. This new head is rather the head of the reversed. So you say front will be heads next because that is what matters. So if you remember over here, this was pointing to this and this was pointing to null when you got the answer. So you already have the front over here because head is still pointing to front. So you get it. After that you say, okay, front, your next can point to head, your next can point to null. And this works because at every step, whatever is your head, whatever you're passing as head, that will always point to null. And after this, you can return the new head. Simple. So it's time to do our famous dry run of the recursion algorithm. In all problems, I will be doing similar dry runs. What we get initially is this. What are the values? 1, 3, 2, 5. Yeah, 1, 3, 2, 5. This is what we initially get. So what happens? Is this true? No. Reverse calls this. So the call goes over here. Now when the call goes over here, what it gets is 3, which is the head, 2, 5, pointing to null. Is no. Again calls the reverse. So the call goes from here to here. And this time this gets is 2, 5 and null. Point to notice is head is this over here. Okay, doesn't works. Goes to reverse. So this reverse calls again another internal function, and this time just passes 5 with null. So this time this base case gets executed and returns head. So let's return head. So it will return head. So what will be the value of new head? The value will be 5. Let me quickly erase this so that maybe I'll keep it. So the value is 5, correct? Let's see this. Front equal to head next. So this is your head as of now. This is your head. So the front stands here, right? So what happens is front equal to head dot next. So front stands here. Front next equal to head. So front's next points to head. Perfect. Head's next point to null. Returns new head. Remember this. Returns new head. And what is the new head? The new head is 5. So it returns 5. So the new head is 5. Let's again do the same thing. So when it returns 5, I can say that the new head has 5, right? What will happen at the next step? We will basically do the next set of steps. But as of now, the linked list is looking something like this. 2, 5. The reversal of 5 has happened and this is my new head as of now. And 2 is pointing to null. Front head dot next. So front goes here. Head is here. Next. Front next goes here. Next. Heads next goes to null. Returns new head. New head, remember, is 5. So it returns 5. So the new head is 5. Point to observe. The linked list has been reversed. You got this. We are returning this. Perfect. Let's do the next thing. So I'll erase this. And I'll also erase this because this is reversed now. And as of now, it looks something like this. 1, you have 3, you have 2, and you have 5. 5 is pointing to this, 2 is pointing to this, 3 is pointing to null, and 1 is pointing to this. This is your head, and this is your new head as of now. And this is your last step of your recursion. Front dot next, head dot next, null. And after this, return new head, and your new head is 5. So if you return the new head, if you carefully observe, is it, after returning, is it reversed? It is reversed. This is how recursion works. You try to solve the smaller version, and it eventually solves your bigger problem. So if I go back to the code editor, I've written the exact same code. I'll try to submit it, and it will be running absolutely fine. If you want to run it for Java, just copy paste the same piece of code, go to Java, maybe just change this to perfect. We'll do a tab. First thing, small, yeah. Let's make it small. Done. What's the next thing? Replace this to dots. Remove the pointers. Dot. Do we have any other dots? I think we have one more over here. Change it. Looks good to me. So what I'll do is I'll try to run this, and it'll be running absolutely. Okay, one more I have to change, dot, and I'll try to submit this straight away, and let's see if it is running fine. It does. So it does run absolutely fine. So what is the time complexity? The time complexity is same, big O of n, because eventually you are traversing through the nodes, because if you look at the number of steps, it is 1, 2, 3, and 4. 4 recursion calls. 4 recursion calls, right? Yeah, you're doing 4 steps, that's okay. So basically the time complexity will be big O of n. What about the space complexity? Space complexity will be big O of n. Now this is the recursive stack space, because when you start with recursion, this is there in the stack. Then you go here, this is there in the stack. This is there in the memory. If you go here, so these things are there in the stack. So recursive stack space is big O of n. So this will be the time complexity and the space complexity for the recursive implementation of linked list. So if you're still watching, I hope you have understood everything. In that case, please do consider giving us a like. And if you're new to our channel, do consider subscribing to us as well. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye. Take care.
Whenever your heart is broken, don't ever forget you're golden.